So now, thanks to opencv's imread function, we have the data collected by the people in the Faculty of Agriculture, by the forestry people, in a way that our computer can understand, and that's already a lot. We not only have the data, but we also have expert annotations, the opinion of experts, in a way that we can also interpret with Python. Very convenient. So let's do just that. We have seen that we have the information of where each patch is in the bigger ortho mosaic. So we cannot work with this huge ortho mosaic in deep learning. It's too big, and well, the information is too mixed up. So what we are going to do is that we are going to try and extract patches from this combination of the ortho mosaic and the binary mask that shows me where the treetops, the bush tops in this case are. Okay, so we are going to want to move from this huge ortho mosaic to a series of small patches, small images, each of them centered around one of these dots, one of these points that mark where the bushes are. If I have that, then I will have like a series of small images of each of my bushes, and that will be much more convenient to work with deep learning networks. The first problem that I have is that I have an image with the location of the bushes, okay, but this is not structured enough. I have, let's get rid of the opacity. I have a binary image and I know where the dots are in the image, but I don't have, for example, their coordinates. This one is at this, you can see it below at the down left corner of the image. You can see it moving here. This is at pixel 10,449 9,573. Okay, great. But how do I make Python retrieve this information from the image that I have at this moment? Well, if you want to achieve that, opencv is very much our friend in this case. And we will use a function called cv2 connected components with stats. And you can see a way more about how this function works here. It's a very useful function that we will be using for a lot of things. And basically, this shows to me that if I wanted to solve this problem of moving from a binary image of dots to the coordinates of each of the dots, of where each of the dots is located, if I had to code this from zero, it would take me a while, and I could solve it in different ways, but likely I would end up coding something that someone else has done before. So the point of studying object-oriented programming is that you can use code libraries confidently. In this case, we are calling a method called connectedComponentWithStats of the cv2 programming language, and it's a static method, and that's why we are calling it directly with the cv2 terminology. And we are giving to it an argument, which is the image that we want to segment, and it's returning to us a tuple with several components. At this moment, we are only going to be interested in the centroids one. The centroids contains the list of coordinates of the center of each connected component. In our case, this will be the list of coordinates of the center of each black dot. You may want to observe that we have done 255 minus mask, which means that we are treating our matrix as an NumPy vector, and we are inverting it because, as it happens, we have a mask that's black black information over white background, and this function works the other way around with white information over black background. So we are inverting it with this very simple line, this very simple instruction, this very simple expression. And the function does lots of things, and it can be used for many more things, and we will, but for this moment we only want the centroids. And you might also observe that we are returning the list of centroids, the list of these coordinates, but we are not returning it all. We are avoiding the first position because we are slicing it one to the end. This is because in the first position of the list we have the centroid of the unbounded connected component, which means the connected component that corresponds to all of the white pixels in the image. And we don't want that for anything, so we are just ignoring it. Just calling this function, we get this list from mask function here. We can run the whole thing, and as you can see, it takes no time to process all of this large binary image, and it gives me a list of the coordinates of all the tops that were depicted in my binary image. So we have most of the information, but now we would like to come here and transparency, opacity again. Yeah, sorry, not so much, something like this. Yes, we have the bushes here, and now we want to go inside. So we want to come here closer, and we want to cut the part of the mosaic that corresponds to this bush that we can do here. Of course, I don't have fine annotation, so I cannot cut the bush precisely, but I can cut a square that mostly contains the information that I want, the bush that I want, and some things that I will not be so interested in, but I can easily cut a bush that that accurately enough represents the information that I want. To do this, I'm going to first define a function called patchesFromTops, which receives the original mosaic, a list that we will use this for of the 3 tops coordinates, a size, which will be the length of the side of the patch that I want to cut. Okay, and another technical parameter that we will see in a second. Okay, so what I will do with this is basically call, using a list comprehension, create patch for every x and y coordinates pair in the tops list that I have here. What does this create patch function do? Well, it basically calls something get squared that gives me a sub image of my original image. So I'm slicing my image matrix using all of these limits. Okay, and you can look at them precisely, but basically what I'm doing is that I'm taking the 2 coordinates and I'm setting them plus minus the size of the patch divided by 2 as the limits in which I'm cutting a submatrix out of my image matrix. Okay, that was dense. Let's go over it once again, and you have all the nice description here that you can read on your own and ask me about if you don't understand. But the point is that we have a lot of points that we have given as coordinates, and for each of them, using a list comprehension, we will call the create patch function, and the create patch function just takes these coordinates and uses them to cut a sub image from the original image using slicing and the fact that our matrix, that our image can be seen as a matrix. Okay, we can define these functions here, and now we are ready to just call them. And yep, that's nice that it happened during the video. Well, not so much, but it's okay. Sometimes Matplotlib decides to print things small. Just run it again, and usually it will just get over itself and print them in the right size. Okay. So what we are doing here is that we are calling the patchesFromTop function, which we had here, patchesFromTops function. Okay, and we are calling it with the mosaic and CS, and CS was the list of the centroids. So we have first, in essence, called this listFromMask function to transform our binary mask of tops in a list of coordinates. And now we are using that list of coordinates and the mosaic to cut a patch around each bush, and we get an example of the bushes that we are cutting that we are showing. Okay. To sum up, we have so far loaded the original orthomosaic image and a binary mask containing the bush tops, and we have used simple first the opencv imread function to load that data, and then we have used the connectedComponentsWithStats opencv function to transform our binary dot image into a list of coordinates for the position of each top. Once we have had this position of each top, we have gone over it, and we have taken a small square, a small image square from the original large mosaic using matrix slicing, and the fact that images are also represented as matrices, so we are slicing images by slicing matrices, and we have used that to create a list of bushes that are actually bush images, and then we will be able to work with these images much better with deep learning networks. What remains now is that we have the bushes, but we don't know what class they belong for, and to do that we will need to do something a little bit more complicated.